Hello and welcome back. Hello and welcome back to yet another exciting Maths 1 class on exponential equations. Okay, so we can start off to continue where we ended. I remember in our first Maths 1 class, we did look at a tutorial sheet and we looked at question 1, part A, B, and then part C and D were given to you as some form of exercise to work on. Okay, so I will start off by looking at the solutions for part C and D. Then we can move on and look at two more questions, which is part E and F. All right, good. So we can start off by indicating this is our mathematics class. Mathematics. That's our mathematics class 1. Okay, and we are basically looking at exponential equations. Okay, we're looking at exponential equations. So equations. Good, there we go. We're looking at exponential equations. So I hope you're ready. So if you do remember, I gave you an assignment in the first Maths 1 class where I said solve the equations. The first one was C. We said solve the equations. Let's look at this. We said solve the equations. Solve the equations. Solve the equations. Part C of the equations from the tutorial sheet was that 2 raised to the power x close bracket also raised to the power 3, which is equal to 64. Okay, so you're supposed to solve that guy there. All right, so basically we can use from the left hand side of the equation, we can use one of the laws of exponents, which states that state here I had written to say laws of exponents. Laws of exponents. So I was referring to these laws of exponents. Okay, which is a raised to the power m in brackets. Outside the brackets we have a power of m would be equal to a n multiplied by m. So I'll apply this law on the left hand side of the equation for me to have 2x multiplied by 3, that would be 3x, which is equal to 64. So basically I also use the prime base concept. Remember, we did look at the prime base concept, which enables us to express numbers in exponential form. Okay, so looking at the prime bases that we were using, we had 2, 3, and 5. And looking at the smallest prime base, or the smallest prime number that can be accorded to the number 64 is 2. So we have to raise 2 to a certain power so that it becomes 64. And that number, I believe, would be 6. Yeah, if we say 2 raised to the power 6, that gives us 64. Yes, so 2 raised to the power 6, of course, is equals to 64. And as you can see, so I can substitute 64 for 2 raised to the power 6. So this is going to be 2 raised to the power 3x equal to 2 raised to the power 6, like that. So having done this, I can see that the bases are the same on both sides of the equation. I can apply the logs, or I can just cancel the bases because they're the same. Remember, we did talk about this, and I gave you the importance of using the logs as a training ability when you're solving such problems. But anyway, we can cancel out this part, and that part goes, which we know we'll be using logs to cancel them, so that we remain with 3x equals to 6. And hence, if we divide by the coefficient 3 on both sides, we find that this and that goes. The value of x, therefore, is equal to 2. So here in that equation, the value of x happens to be 2. So this is how you are supposed to solve the question I gave you in the first video. Okay, Without wasting time, we can look at the solution for D. Also, I gave you an equation. I said 16 raised to the power x is equal to 0.125. Okay, so 16 raised to the power x equals to 0.125. First things first, let me express 16 in prime base concept, which is, I know that 2 raised to the power 4 is going to give me 16. That is correct. So I can substitute 16 by 2 to the power 4, so which will be 2 to the power 4 raised to the power x, which is equal to, and I'll express the decimal number 0.125 as a fraction. So we know that 0.125 is actually 1 over 8. We agree on that, all of us. That is 1 over 8. Yes. So now remember that I can say, using this concept here on the left hand side, I can say 2 raised to the power 4x, simply multiplying the 2 as this states here, and also equal to, remember that I can express 8 in prime base form using the prime base concept as 2 raised to the power 3, which is equals to 8. So I can express that as 1 over 2 to the power 3, okay, which is equals to 8. Then remember that I have there's a law that a raised to the power negative n is equals to 1 over a raised to the power m. Okay, so this here, as you can see, 1 over 2 to the power 3 can be expressed as a raised to the power negative m. So this can be 2 to the power 4x equal to 2 to the power negative 3. But like I said, the bases have become the same. I can apply logs and cancel out the 2's as I was doing in the first class where I showed you how that works. But also a shortcut is simply the bases are the same on both sides. We can just cancel this base and that base out so that we have 4x is now equals to negative 3. And so we can divide by the coefficient on both sides. And that goes so that x is therefore equals to negative 3 over 4 as our solution. You can leave it as a fraction form. That would be fantastic for us to work with. Okay, so that is how those solutions were supposed to be given. Okay, so now in our math class 3, we look forward to solving some more questions that will help us understand how to use exponents on equations that tend to head into a quadratic equation. All right, thank you, and looking forward to solving the next tutorial question with you on our online lessons. All right, thank you.